Today's project, it is about switches, this kind of switches. I don't know if you have seen, but there are some switches out there that they have this little window, and that window is in order to introduce a little light when it is dark around. That little light help us to identify where is the switch in order to turn on or turn off the lights. But what I happen to see, it is that this little LED inside, it is always on. Even if we have the lights off, this little LED remains on. But that is something that we really don't need. And I try to find with the suppliers of these switches if there is some kind of circuit that let us avoid to have that little LED on when it is light around. And I couldn't find any. Actually, they have that system, but for the light for the house. I mean, if there is a little darker already and you need a source of light in some place, then if it detects movement, then the light turns on. But if it is light all around and it detects movement, it doesn't turn on the light because there's no need for that. So what I try to do here is to apply that concept for the little LED that we have here, but obviously to turn on not with detecting the movement, but only for detecting if there is light around or if it is too dark, then the little light inside here will show up. So that is what I wanted to do, and I don't have the enough knowledge in order to do some kind of circuits, but I am curious and I try to search over the internet, and actually I found how to convert the alternate current to direct current, which is what I need because these little LEDs, most of them always work with direct current. So what I found, it is a circuit to convert the light, and after that I tried to find if there was something, some element that helped me identify when there is light around or if it is dark, and I found it. And that element is what they call the LDR, which name in English it means light dependent resistance. And that is actually what I wanted to put, because this little element help us identify if there is light around or if it is all dark. So this element is going to conduct the electricity through it, or it is going to avoid it. So that is what I was trying to find. And also I need a transistor in order to help this LDR element to work properly. And actually I'm gonna show you how is that I came up with that circuit board, because I tried to find if there was something with the suppliers of the switches, if there is something like that, but it doesn't exist. So I just tried to figure out how to do it. And mainly what I just did is to combine two circuits. One circuit was to convert the alternate current to direct current, and the other circuit was to allow me to use the LDR element that I am telling you. And the only thing that I did is just to match them together, and it worked pretty good. Let me show you the diagram that I did so you can understand better. Okay, this is the circuit that I made. In order to have these little LEDs that you see here, some cases we will need to have over the light of the room a capacitor, because if you turn off the light, there is a remnant current. So if you have LED lights also in here to illuminate the room, then you will have some flashes over it, and they will not end. I mean, over that light, you will see how the light flashes. Once I have explained that, why is this capacitor there, what you can see here, this is the switch. It is mainly the back part. They come like this, or they have a different configuration. Here you can see that there are only 2 holes, but that depends on the supplier that you choose. First, we have a resistance of 470, then a capacitor, 0.42 microfarads. And this is how I will be converting the alternate current to direct current. This is a diode bridge, and after that we will have direct current in order to put the LEDs to low a little bit the outside voltage that we will have, because LEDs work around 2.2 or 1.5 volts. So I will have to configure it in order to have that voltage. So here I will be getting 3 volts, and this is the transistor that I used. It's 2N2222A. This element is the one that it is going to react with the LRD. It is connected to one spot here, and the other spot is also here. And this is the one that it is going to allow or avoid to pass the current through the LEDs. This is the element that it is sensible with light. So if there is no light, then the current will flow and the LEDs will remain on. But if the LDR detects that there is light around, then it will avoid the pass of the current through the transistor, and then the LEDs are going to be off. They are not going to show up. Well, mainly this is the circuit. Obviously, I made this in an electronic circuit board. I had an uncle whose specialty is this kind of things. He's an engineer for the electronics, and he provided me help in order to build the board. And he just showed me that there's a software where you can configure this and then print it over the board, and then you can have the circuit and just weld over it all the elements that I am showing here, and that way I could make it. Okay, here we are. Actually, we have 2 of those switches, and this is the LDR that you can see there. And I didn't have a space how to put it, so I had to make a hold over this part in order to the LDR to show up, so it can detect if there is light around or if it is not. And as you can see right now, the little LED will show up here over these spots. It is where it is located. But right now, because there is light around, this is acting, so there's no need to have a LED that it is inside here to turn on. So right now it is off. But as you can see, if I just cover it, there you can see how the LEDs start to show up. They are now on because I am covering the LDR. So it is detecting right now that there is no light around. So when it is night and we don't have enough light around, we can easily identify where the switch is. Right now, as you can see, I just letting my finger to let the light go by. So you can see right now that both LEDs are off. So as you can see, they don't show up. And if I cover, they turn on, they turn off. But I just configure it this way. But for example, if I turn on this, which is the closest light, and that is the light that it is here, and even if I cover the LDR, it is not going to light up, because obviously you have the light on here, so there's no need for you to identify it. But if I turn off this and I turn on the light that it is farther away, if I cover it, then you can see how the little LEDs turn on, and if I turn it off, it is the same. The circuit board that I made, it was very little in order to can introduce it, and we have enough room in there. And as I said, I am not a specialist about doing those kind of things, but I did it, and it has passed like about 7 years maybe since I've made those, and they are still working. And also with that, we can save some money. It is not that much, but they accomplish their functionality. When there is a lot of light around, they are off, so they don't need to light on, and that way we don't consume electricity at that times. Only for the LDR, for the detecting when there is light around or not. And that is it. That was the project. Well, hope you like it.